Hello and welcome to the Learning Square. Today I will introduce you to PANDAS, which is essentially a software library built in Python for data analysis. PANDAS is actually an open source library built on top of NumPy, which we had already studied earlier. It allows fast analysis, data cleaning and preparation. It excels in performance and productivity. It also has built-in visualization features. It can work with data from wide variety of sources. So to be able to install PANDAS, you can go to the command line cmd and you can just maybe write conda, because I've used the Anaconda installation, so I just used conda install PANDAS, and I had something like this come over. So it just unpacks the entire package. You go ahead and then you can start your Jupyter notebook. So Ceres is a one-dimensional labeled array capable of holding data of any one type. So you could have integers, strings, floats, Python objects, etc. And this is equivalent to a vector in R as well as a vector in MATLAB as well. So the access labels are collectively called the index, and these are nothing but a column in an Excel sheet. So when we look at data frames, it is actually a collection of a lot of series there. So to get started, here I have the Jupyter notebook. Now let me create some different data types here. So I have here a list of strings here. So I have given names here ABC, BCD, CDE and DEF. This is a list. Let me create a labels list also. I could have numbers here. Let me create an array using NumPy, but I haven't imported NumPy. So I'll just say import NumPy as NP, import pandas as PD. Now I'll be able to create an array here, so I'll say np.array. Let me create an array of these labels that I have. If I look at array, I have a one-dimensional array here. So let me also define a dictionary here, wherein I use these indexes and the names that I had, the S names. So 102. So let's look at the data that we have. So I have a dictionary. So I have different data type here. I have an array, I have a list, and I also have a dictionary. Now let's convert it into a series. So I'll just say PD, because I've imported pandas as PD. So PD dot series, and I give S name here. Now here you can see that this is a series has been made. If I look at the type of series, so maybe to understand the type, I'll just name it to A. So I've named this to A. If I want to check the type, you can see it is a series now. Let's create another series here. So I'll name it B, and let me create a series of labels. Let's look at B. So B is again a series. So this is your index here, and this is the data value that I have. Now let's give an array inside the series. So you can see the array is also converted to a series here. If I shift tab here, you'll be able to see that inside the series I have the first argument is my data, the second argument is the index, then my data type, name, copy, fast path. These are all optional. Everything is optional, but I need to give some data. Here let me give the data and index. So let me give data as S name and index as the labels. So here you can see a series is created. The index is now my labels and the data is now the S name. Now the interesting part is that if I give a dictionary as the argument here, you will see that it automatically takes your keys as your index values, and the data value is taken as the data here. Now let me create two series here, S1. So let me give indexes of 1, 2, 3, 4, and my data could be maybe some abbreviations of states. Let me create another series. Here I'll change it a little bit, and let me just copy the same for same indexes. So I have these two series defined. Now if I add these two up, what's going to happen? UP was present in both, so 1 plus 1 gives me 2.0, and they are converted to a float automatically like in NumPy. Tamil Nadu was present in both, so TN was 4 here, TN was 4 here, so it becomes 8.0. MP was present in both, so it becomes 4.0. The ones which were different from the other list have been copied, but then addition has not been done, and it says it's not a number. So what it does is, it adds values for common elements, rest have a NaN value. So with series you could do these operations. If I do S1 minus S2, similar thing happens here. Now if you look at series, they are not actually used much, so we will just stop the lecture here, and I will get on to the next lecture on data frames, which are heavily used in data analysis. So I'll see you in the next lecture. Thank you.